this is the impossible integral if we try to integrate it in the way it is. But it's possible if we try to change the order of integration. Yeah. So we'll want to change the order of integration. We'll want to make it in the divide dx form rather than dx dy, because when we try to integrate it like this is virtually impossible, or it's hard anyway. Okay. So if you want to change the order of integration, we perform a certain operation like this. Yeah, we perform uh, this operation, which I'm going to do. Yeah, here x we have y running from 0 to 8 and x running from cube root of y to 2. So we are going from 0 to 8 in the y world, and for every value of y we are running from cube root of y to 2. Yeah. So we are running from x equals to cube root of y, that means y equals to x cube. So y equals to x cube is something like this. Okay. So this is y equals to x cube. Okay. And so corresponding to 8 we have a value 2 over here. Okay. So this is y equals to x cube. So, and x values are running from cube root of y to 2. So for y value, the cube root of y value will lie here, since this is x equals to cube root of y. So x are running from cube root of y to 2. Yeah. So for every values of y, x are going from cube root of y to 2. So this is what we are shown in the limits of integration, and the values that's in the middle is just the height of the 3D figure that's lying in the space. Yeah. So basically these limits of integration are denoting the space area, y going from 0 to 8 and x going from cube root of y to 2. So now if we want to change the limits of integration, we need to first have dy and then dx. So basically we first want x to run. X goes from 0 to 2 and y goes from 0 to x cube. Yeah, 0 to x cube. X goes from 0 to 2 and y goes from 0 to x cube. Yeah, and then we will have the same height or integrand and then divide dx. Now in this form it will be possible to solve this integral. Okay, so we have this integral from 0 to 2, 0 to 2, and then from 0 to x cube, x to the power 4 plus 1 dy dx. Now we earlier had to integrate this expression, but now this is constant in the y world, so it's going to be easier for us. Root x to the power 4 plus 1 times y is our integral, and going from 0 to x cube dx. So that will be integral from 0 to 2 square root of x to the power 4 plus 1 times x cube minus 0. Okay, and dx. Now I guess this is integrable. So for this integration, what we can do is we can let x to the power 4 plus 1 as g. So if we do this, dg by 4 equals to x cube dx will be there, and now that will be a lot easier for us. And if we change the limits of integration, this will be from 1 to 17, and here we have root of g dg by 4. So that will be 1 by 4 g to the power 3 by 2 by 3 by 2 from 1 to 17. So that would be 1 over 6, 17 to the power 3 by 2 minus 1. So I guess this is the answer. Yeah, this is So we have solved the seemingly impossible integral, and this answer is 1 by 6, 17 to the power 3 by 2 minus 1. Okay, so you might have noticed that changing the limits orders of integration can help sometimes, and that was the aim of this video. Thanks for watching. Look forward to seeing you in the next video.